Hi guys, this is Miss Rapp, and today we are working on Unit 2, Lesson 2, Domain and Range of Functions, page 51 to 57. So please make sure you have the right notes out, and let's get started. I would like everyone to take a moment on their own, read the opener, and pause the video and try to answer these two questions. So here are my answers. We can plug in anything to the absolute value. All x values are allowed to be plugged in, but we will not get any negative numbers as our answer because absolute value makes everything positive. So today we are talking about domain and range. So domain is the set of all possible inputs in a function. So domain is talking about your x values because x values are inputs. The range is talking about the set of all outputs in a function. So inputs go in, outputs come out. So there's a few ways to talk about this. We can do words, interval notations, and inequalities. So verbally, you could say the domain is all real numbers. What that would look like in interval notation would be so negative infinity to positive infinity, right? That's addressing all the real numbers, all numbers. Sometimes people put the plus at the infinity, sometimes they don't. Either way, you are correct. An inequality example could be, let's say we're talking about the range. I could say the y values must be greater than or equal to 8. We will mostly be using interval notation for this course. Okay, so this should look a little bit familiar because this is after the mother functions unit. So reference your graphs from unit 1 and identify the domains and range for our mother functions. Remember, transformations will alter these domains and ranges. So these are the basic functions. So when they're talking about domain and range, they're asking, what am I allowed to plug in? So domain is asking, what am I allowed to plug in? Range is saying, okay, well, what comes out? What's the outcome? So in a linear equation, you're allowed to plug in whatever you want. So this is all real numbers. And the sign for that looks like this. It's a line with an R. Use either one. The range, the outputs, are also all real numbers. A quadratic, I can plug whatever I want into here, negatives, fractions, pi, whatever. So I'm allowed to plug in whatever, so that's all real numbers. But my range is not going to be the same because if you think about a quadratic, only these y values above are being hit. So 0 to infinity, and I put a bracket here because it sits on 0, a closed bracket. Absolute value, you can plug in whatever you want, but it'll only spit out 0 or positive numbers, right? Absolute values don't have negatives. The exponential, I can plug in whatever I want to my domain. I can put a negative, I can put a fraction, I can plug in whatever. But the outcome will only go from 0 to positive infinity. And the reason I put a parenthesis here, 0 is an asymptote. So it actually never sits on it. That's why it's an open parenthesis. Square roots, I can't plug in negatives, right? Like if I have a -4 in here, we can't graph that because we can't graph imaginary numbers, which we'll get to in a later unit. So for now, when graphing, our domain is 0 to infinity. We only want to put positives in there. And our range, because we're only putting in positives, we're only going to get out positives. The cubic, I can throw whatever I want in there. I can cube anything. And the range will follow. You can get negatives out, you can get positives out, just depends on what you plug in. This will also apply here. So same rules for the same reasons. So with rational numbers, rational functions, I cannot have my denominator be 0. Otherwise, you get an error on your calculator. It doesn't exist. So I can plug in every single number but 0. So this means I can plug in all of my negatives, stop at 0. I can plug in, skip 0 again, and I can plug in all of my positives. Therefore, my range will be the same. So I would just say here, denominator cannot equal 0. And that's a very big thing to remember. Okay, so what type of transformations will affect the domain? So think back, okay, well, what's going to affect my x values? So my x goes from left to right. That's my side to side. So that's a horizontal transformation. So my range is my y. So I'll put an x here and a y here so we can remember. So this will be a vertical transformation. Let's look at it. Okay, so here's the mother function, and I can plug in whatever I want to x squared, no rules. But everything I get will be positive. So 0 to infinity. Okay. But right here, my vertex is at -1, -5, and it's facing up. So my function's facing up, which means that this is my, so I can just even sketch this. So it will never be below -5. So my domain, I can still plug in whatever I want, no rules there. But my range is actually shifted. So now we'll never get below this -5. So we'll say -5 to positive infinity, because all the values have to be above -5. So visually, it's pretty easy to find domain and range because you can actually see what numbers are going to be covered. So scan the graph to determine which values of x and which values of y the graph covers. Always be thinking about the mother functions. So this is an absolute value. And when I'm looking at my domain, I'm looking from left to right. And it looks like all of the x values are being used. So that's -infinity to positive infinity. My range is up and down. There is nothing below -5 being used. Everything is -5 and above. So -5 and higher. For the next one, it's a quadratic and it's facing down. So I can plug in whatever x values I want to a quadratic. What's going to be affected is my range. So I never get higher than -2. I use all the negative numbers underneath it. So I would say I go -infinity to -2. These next two are not visual problems, so we need to think about what they mean. Okay, our mother function, the cube root of x, can do whatever it wants. I can plug in whatever and I can get out whatever. There are no restrictions on cubes, so that stays cube roots. There are no restrictions on cube roots. So I can plug in whatever I want and I can get out whatever I want. Number 4, well, in the mother function, 1 over x, we know that the denominator cannot be 0. So I'll put an even star here. Denominator cannot be 0. So we need to be a little bit more specific now. My denominator cannot be 0. So let's solve for x. A little bit of algebra review. So we say x cannot be -2. So to represent that in our domain, it can be every single number in the world besides -2. So we have to kind of skip it. So notation-wise, -infinity, we go up to -2 and we stop there and we skip over it. We union it, and then we go -2 to infinity. Okay. So we have to know how to do it visually and algebraically. So looking at this, my domain is just all my set of x values. So my domain, and don't worry if you can't draw those squiggles, all good. So I see that there's a point at x is -3. I see there's an x value at -2. I see there's an x value at -1. X equals 0 is an x value. 2 and 3. So then my range will just be all the y values. So I see that there's a y value of 2. It happens twice. You don't have to say it twice. I see there's a y value of 5, 6. That happens twice as well. And 8. So when it's just some points plotted, it's just the numbers. Okay, this one looks different. This is called a piecewise function. So domain, we're gonna look at our x's, ranges, we're looking at our y's. So my domain, I'm looking side to side. So right here is the first x value on the left, and then here's the last x value, which is going to infinity. So I would say that from, what is that, -7, and all of these holes get filled to infinity is my domain, because I use all of my x values from -7 to +infinity. So my range, I'm thinking up and down. So this is my lowest y value, and this would be my highest y value. Lowest y value, highest. So my lowest y value is -6. And I use a closed bracket because it sits right on -6. And then because, you can see this, because that has an arrow, that means the height goes on forever. The y values increase forever. So we are also going to +infinity. Good job, guys. Scroll back if you need to do anything else again. Thanks.